Okay, welcome to ETCS5200, Artificial Intelligence and Machine Learning 1. This is class 1 of that course, and today we're going to do a course introduction, a little bit of a content overview to introduce you to the material, give you an idea of where this class is going to go and where it's going to finish up by the end. Now, before you get too much farther along, my name is Paul Yost. This is me. So hello. You'll be interacting with me, going through the lectures with me throughout the semester. You might be interacting with me on chat or in office hours via telephone or maybe in person. Depends on where you are and how you're interacting with me throughout the semester. But welcome to the class, and let me give you a quick rundown of what we're going to be doing throughout the semester today. Don't have a lot of slides to get through today, but I do want to give you an overview of what to expect, what we're going to cover, and then starting the next class, we're going to start hitting the ground running and getting into some actual material. All right, so let's go ahead and get started here. So first off, each of the slide decks has a page that looks like this at the beginning. It's really going to be slide number 2, where it has the course number along with the class number. And then below that, which you don't see right here, but below that is going to be a link to the YouTube video presentation of each of those lectures. And what that will allow you to do is either watch the video presentation, or since you will have access to the PDF version of the slides, you can always go through the slides without the video presentation. Now, the advantage of that is if you're looking for something very specific, you don't have to wade through the all of the video content to find the one thing you're looking for. You can just look at the slide deck, scroll ahead to whatever page has whatever content you're interested in, look at that. But the other advantage of that is since page 1 or 2 will have that link to the YouTube presentation. If you do want to go back and review the material, something you were fuzzy on, you want to have it, take notes, pause things, try something, rewind, revisit the material again in a presentation format, you can always watch the video and follow along with the slide deck, or just watch the video as you go. So just note that every one of the slide decks is going to have the full set of slides in a PDF form, and on that second page will be a clickable link that will take you to the video presentation. All right, so let's actually get into some material. Before we do that, let's look at what it is we're going to cover today. So what we're going to cover is going to be first off, the syllabus. And the syllabus, we're going to get into some of the details of that as we go. But the idea is I just want to give you an idea of what to expect, what the kind of requirements are for the class, what should be expected of you, what you can expect of me. And we'll go over that. We'll also go over the course content overview, the course modules. In other words, this class is divided up into several distinct units. And those units, we'll get a brief overview today of what you can expect from those. And then we're going to finish up with a little bit of kind of my teaching philosophy and the philosophy that's going to guide this class that might help you understand where we're coming from and how we're going to cover the material in here. So let's just go and get started and dig right in. Now, first thing is the syllabus itself is divided up into 6 sections: instructor information, course information, and then a course outline. And in that course outline, it has the course objectives and student learning outcomes. That can be useful. Course outline gives you kind of an overview of the content that we're going to cover. And then the objectives and the learning outcomes, that gives you an idea of like what it is we're trying to do with the class, and then what you can expect kind of at a very high level, very abstract level by the end of the class. So that if you want to read through those, we'll take a brief look at those today. If you want to look at those, that gives you a nice overview of what you can expect from where we start to where we end up at the end. Part 4 has a schedule. That schedule is going to have some flexibility built into it. So, for example, it's largely going to be what we cover. It might be that, for example, if I realize that we're having trouble with a concept, we might stretch some things out. We might have some assignments that we drop off of the schedule if it looks like we're getting behind on some things. There might be, if I think of a really spectacular assignment along the way and it's not on the schedule, I might add something in. I might add bonus point kinds of things in. So it is pretty accurate for what we're going to be covering and what we're going to be doing. But note that there is some flexibility there with adding things in, dropping things out. So my goal is to kind of make sure that I'm doing the best job at teaching you this material, conveying it to you, and that requires a lot of times having some flexibility. So keep that in mind. Now, the grading policy, part 5, and then the course policies are part 6. All right, so let's go ahead and continue on, get a little bit farther into some actual details. So first off, instructor information. That's me. My office is 307 in the ATC building on the Shawnee State University campus. If you're remote, you can always contact me by email or by phone, or use the chat feature on the course site itself. That is my mobile number, so you can text me if you need to. Also note that the syllabus does have a brief bio of me with information, so feel free, if necessary, to read that. That is required by the state now that we post that. It's basically, they want students to be familiar with the instructor and our qualifications. So if you want to read that, you can. I'm not going to spend a lot of time going through that. But if you're interested, feel free to read that. Now, my office hours, those are posted on the course site. Feel free to look at those. That way you know when to contact me or stop by or reach out. And quick note about the office hours. They are posted on the syllabus and on the course page. I am also available to meet face-to-face or video chat or phone calls at other times as well. Just contact me, set up an appointment. I can be very flexible with that. So don't worry if you have something going on. Don't worry like, oh, it's not office hours time, I don't want to bother him. Feel free to reach out and we'll set things up. Now, one note about email though, I do try to catch up on email during office hours, but I do get behind sometimes, and I do prioritize in-person meetings. So I may not get to your email immediately. I do try to keep up with that. But if you do need something urgent and you need a response quickly, call me, send a text message. That's usually your best bet if you have some urgent need. Otherwise, send the email, just be patient, and I'll get back to you. Same thing with the chat. If you put something in chat, I may not see it immediately. So again, if you need something quickly, you have a really urgent need, send a text message, give a call. If you do call though, leave a voicemail, especially if we haven't talked on the phone before, you haven't texted before. Just like everybody else, I get tons of spam calls, so I won't answer the phone if I don't recognize the number generally. So if you call, leave a voicemail, I'll call you back, and then I'll add you as a contact for the next time. Now, let's go ahead and get into the course description for what we're going to be doing. It's kind of in the title what we're doing here, Artificial Intelligence and Machine Learning 1, which shows that it's the first in a two-part class sequence. But the course description here basically says it's an introduction to the foundational principles of artificial intelligence through hands-on development of intelligent systems. Students explore formal definitions of intelligence, probability, entropy, and information gain while building decision trees, classification models, and Markov chain-based language systems. Emphasis is placed on constructing systems from first principles to understanding prediction, uncertainty, and data-driven decisions, or data-driven decision-making without reliance on black box frameworks. Now, there's a couple things in there that I want to point out. that I think are important uh, or worth mentioning. The first is that first sentence mentions through hands-on development. We are going to be not just talking about things. You guys are going to be making things and doing things in this class. I think that's one of the best ways to learn things is to get your sleeves rolled up and your hands dirty and actually build some stuff and write some stuff. The second thing that I think is important to point out, which is related, is if you look at that last sentence there, it says emphasis is placed on constructing systems. Again, that's building stuff from first principles. That means that we're going to be building stuff first from first principles. Means largely from scratch when possible. In other words, I want it so that we understand what's happening rather than just play with something that's already built. And you can kind of see that with how that sentence finishes up as well, without reliance on black box frameworks. I want this class to be about a deep and broad understanding of what we're doing here. So we're going to be learning a lot of stuff, building a lot of things. It's going to be a lot of fun. And my hope is that rather than just saying, here's a tool that somebody else built, let's play with it, we're going to be able to build our own tools and then play with the stuff that we build. And that way we're going to really, truly understand that stuff. Now, the kind of course objective and philosophy, which you could kind of see this coming through in that course description, it's designed to be that nuts and bolts understanding of how artificial intelligence and machine learning systems are built and operated. And the reason for that is, again, I want you to have this really foundational understanding of what's happening. And so that means we're going to be writing code, we're going to be solving problems, and that's going to give us this mastery of the material. Now, I don't want you to be intimidated by that. We are going to cover what we need to cover to write that code. We are going to cover what we need to cover to solve those problems. So what might seem mysterious and difficult or magical right now, we're going to kind of dig down into those things at low level and learn that how those things work is actually completely understandable. And in order to do that, we're going to avoid those black box mysteries that hide the magic away. We want to dig down into that and understand what the man behind the curtain is doing. And so we can be that in those systems. We want to understand those inner workings. Now, the key topics that we're going to cover in here, and this is in the syllabus, kind of definitions of intelligence. So we want to, if we're going to be studying this, we need to at least have some way of discussing it and thinking about it. So we're going to be talking a little bit about that. That's sort of a philosophical question, but we're going to talk about that. We're going to then spend a little bit of time talking about some data structures and programming concepts related to the material that we're going to need for throughout the semester. We're going to then dig into some sort of mathematics related to this. And again, don't be intimidated by this, but information theory is sort of the mathematics of patterns and probability. And since a lot of intelligence is recognizing patterns and extracting those patterns and predicting things, that information theory really gives us a nice way to, in a kind of formal way, wrap our minds around what it is we're talking about with those sorts of things, like rather than just saying the word pattern or language or understanding. We want to have something a little more formal to discuss that. Information theory is going to give us a way to do that. And then from there, we're going to use that information theory stuff to move into using that to make decisions with things called decision trees. We're going to use that to look at things like language, which is entirely pattern-based. As I'm talking here, there's a grammatical structure. There's a collection of sounds that you're listening to and interpreting and understanding. Really, you're just processing those patterns and parsing them into an understanding of the ideas that I'm conveying to you. And that we're going to be talking about that. And then we're going to get into another kind of mathematics called Markov chains, which allow us to have a method of predicting sequences of uh, events that uh, are related to pattern production in probabilistic systems. We're going to play around with that with language. And then we're going to kind of finish up by combining all that stuff at the end here by using those techniques to make a chatbot. Now, the chatbot we're going to make this semester is going to be a little bit different than large language models that you're used to using. It's going to be based on these more classic probability methods. But what we're going to see is that even with the stuff that we're doing this semester, we're going to be able to do some really fun and interesting stuff. Next semester, we're going to get into more of the neural processing, neural-based computing, and large language models. You'll see that next semester or the next class. Now, a couple things that you're expected for this particular course to be successful. This is a master's level class, so acceptance into one of the computer science master's programs is expected, or completion of the ETCS 4501 course, which gives you kind of the data structures and computing foundations that you'll find very helpful in this. We will cover some of that and review some of that additionally as needed. And you can also get instructor approval. So you could be in this class basically if you just have an interest and seem to have the skill set and have talked to me, you can still be in the class that way. Now, as far as skills themselves for being successful, I don't expect you to be like a super hacker, master programmer to be successful. We're going to cover what we need to cover throughout the semester, but some arithmetic skills, algebraic skills. We're not going to be like solving a lot of algebra problems, but those skills are going to come in handy. Those ways of thinking are going to come in handy. Also, just general problem solving skills, thinking through, okay, here's this problem I have to solve. How could I think through a way to come up with a solution to that? And then on top of all that, prior programming experience, we're going to use Python. But if you have programming experience in another language, I don't know, C++, Java, something along those lines, that'll translate pretty nicely as well. So as long as you've programmed in some other language and understand kind of that algorithmic thinking and problem solving, that's going to go a long way to being successful for our lab component. And then obviously, I would hope that everybody has this sense of excitement, sense of curiosity about the field itself, and then a desire to kind of learn new things and play with the stuff that we're going to do in here. And we are going to have a lot of fun this semester. So that if you're excited, if you're curious, then the learning in this is going to kind of take care of itself. There's a lot of really cool, really fun stuff that we're going to do this semester. And we'll get into that shortly. Now, the course structure, basically, I already mentioned this a little bit. We're going to have lectures, which are going to be video format like this. And like I said, the links to the video lectures will all be posted on the course site along with the PDF of the lecture slides. Those will be one and the same. The lecture slide PDF will have the link to the video on the first page. And then other resources that you need. For example, I might post sample code. That will get posted to the course page as well. I may post other supplemental material, other resources that will get posted to the course site. And then throughout the semester, we're going to have assessments. So there'll be some assignments. Some of the assignments will take the form of programming labs. Some of them will be the form of these little check-in, almost like little quizzes that you'll have to take. Some of them will have some written component where you experiment with some things and then write up what your experiences were with that. And then there will also be some chat room participation in the online portion of this. One thing to do, though, as you go, there'll also be 2 exams, a midterm and a final. One thing to watch out for throughout the semester, there's watch out for the due dates on those assignments and quizzes and lab assignments and exams. Make sure you're aware of those because that is going to be important for you to keep up with that, keep up with those things, keep up with the schedule as you go through the semester. So try not to get behind. We want to keep everybody in sync as much as possible. If you get behind, it's kind of like a train. Once you're off the track, it's harder to get back on. So if you are struggling with things, reach out, let me know. If something comes up, an emergency, let me know. Just keep in contact with me so we can make sure that we're proactively doing what we can to make sure you're not falling behind. Now, quick outline of the course itself. Like I mentioned, it's divided up into different units. This class has 5 instructional units as listed here. So Foundations of Intelligence, that's where we kind of just talk about what intelligence and artificial intelligence is. And then we're going to move on to a little bit of a review or coverage of the kind of data structures that you're going to be using throughout the semester. Some of these you've probably seen before and used before. Some of them may be new or covered in a slightly different way, but we're going to use these for some lab assignments and for building some stuff throughout the semester. So we'll review that. We'll cover those things. Then we're going to move on into the information theory part, learn some of the mathematics behind that, learn why we want to use that. Then we're going to use that information theory for decision trees, and then move on into using that for language and language modeling, specifically with both information theory and Markov models, Markov chains. Now, all of these things are specifically related to kind of the symbolic and probabilistic aspects of machine learning and artificial intelligence. Next semester, it'll be more the biological, neurological models of artificial intelligence. All right, so moving on from that, quick overview. Quick review of the grading policy. The grading policy, 40%, so the largest percentage is the work that you do, homework, programs, projects, quizzes, chat participation. That's the bulk of your work. That's the bulk of your grade. And then we have 25% for the midterm exam, and then 35% for the final exam. Now, one quick word of that's worth mentioning is that you do have to get a passing grade on the final exam to pass the class. That's kind of like you can't really move on to the second class in the sequence without having at least a passing level of understanding of the material in this class. So you do, in the final exam, is kind of the gatekeeper for that, to make sure you learned what you needed to learn to move on to the AI and Machine Learning 2 course. So do take the final exam seriously. If you did the work here and you followed along, it should not be difficult to get a passing grade on the final exam. So don't stress too much about that. But do know that you do not blow off the final exam and say, whatever, I'll just phone it in, because you do need to pass that to pass the class. Now, here's the grading system. One thing you'll notice with the graduate school class is that it does range from A to F, but there are no Ds. So generally in grad school, anything below a C is considered not successfully completing the class. So we've stretched the grade scale downwards. That does make a little bit wider band for A up at the top. And since we're going to be doing a lot of work and a lot of programs in here, that gives you some latitude to miss some things or have some missteps when you're creating some of the stuff. And this is probably a pretty good grade scale. One of the things that notice at the top is it'll be no worse than this. That means that I may curve the grades to help the students as a group. But I'll never curve the grades to hurt the students. In other words, there are some professors where they want the grades to look like a nice standard distribution model, and so if everybody was in the 90 to 100, then they'll redistribute it. So now the person that had 90 is now at a C or D or whatever. I'm not going to do that. I basically would hope everybody does really well in this class and learns all the material. My goal is the grade is your measure of how well you learned the material that I presented. And if everybody does a fantastic job of learning this material, proving to me that you learned the material or showing me that you learned the material, you're all going to get really good grades in the class. If, however, you come to the final exam and you take that and it looks like you did really poorly and you did not learn the material, you're going to end up in that, I don't know, let's say you got a 55 in the course or on the final exam in the course, you're going to unfortunately get be in that F range. So again, do take the final exam and all of the exams and other things seriously throughout the semester. Now, course policies. Let's just take, I could switch over to the syllabus and we could look through all of those, but I'm going to hit some highlights here in the lecture slides where it's easier for us to see. You can always review those course policies directly in the syllabus itself if you want to, but my course policies, let's just hit the highlights here. You can read the rest of it in the syllabus if necessary, but the completing assignments and due dates, each assignment will have a due date. If an assignment does not have a due date, then it would be the last regularly scheduled class of the semester, but all of them will have a due date. And if you are having issues with meeting a due date, reach out, communicate, let me know. That way I could say, oh, okay, maybe you were sick, you had a sick child, whatever, or you're just struggling with the material. Don't just give up on it and reach out to me. Let me know. I'll do what I can to help you. I'd rather have you reach out. Maybe I'll give you an extension if it's warranted, if you have a legitimate reason to need that. But reach out, talk to me. I'll help you as much as I can. I want you to learn the material. I don't want to punish you and have it be a Machiavellian, draconian system where I'm making you pay for being 10 minutes late. I want you to learn this material. And sometimes that might mean having a little bit of flexibility with due dates and working around everybody has lives. Just if you're having an issue, talk to me about it. Communicate. Now, other course policies, academic integrity. Don't submit work that isn't your own. The whole point of this class is not to get through it. The point is to learn stuff. So don't fake scientific results or copy work from someplace else or use a large language model to generate data or a solution or download something that you found on the internet that wasn't your work. Again, this class is for you to learn stuff and for me to kind of help you learn stuff. And the only way I can do that is to have an accurate gauge of where you are and how you're doing. So don't plagiarize stuff or turn in things that isn't your own work. Now, my AI policy, this is an AI class, so it's not like I'm going to say you can't use AI at all, but there are going to be some guidelines that I'll expect from that. Relying on it to do your work for you will ensure that you don't learn anything. Again, the point of this class is to learn stuff. If you're using it to help you learn, that's great. If you're using it to avoid learning, that's terrible. Again, the stuff that you turn in, your work product, you should understand that it should be your intellectual work product. It should be something that you did and understand that you turn in. Now, here's some guiding scenarios that are in the syllabus that kind of should help with that. So again, my suggested policy is if you're using it as a tutor or as a learning aid or to explain things to you to help you learn, that's good. If you're using it to avoid that or as a shortcut, or if you're using it to be lazy, to avoid the hard mental effort to learn the stuff, then that is not good. So here are some good and bad. Unfortunately, I don't have any uglies on here, but I guess if you only use AI and don't learn anything, it's going to be ugly when you get your final exam grade back. But the AI policy here, as far as good, using it as a tutor or learning tool, having it explain something to you, fantastic. Bad, using it to write your code for your programming lab. So in other words, just giving it your programming lab, taking what it told you, and then turning that in as your own work. Bad. You won't learn anything from that. And then here's another good, using it to explain a difficult concept that you're struggling with. So in other words, if there's something in the class, you watched the video, you looked at the slides and you're still confused about it, it's always good to have somebody else explain it in a different way or have maybe more detail. Maybe you go to a large language model, ask it to explain the concept, and then maybe ask it for different examples or something like that. That is a good use of it. Bad, using it to write short answer questions, responses for one of the assignments that we have. So in other words, if you're using it to avoid thinking, that's bad. If you're using it to help you understand, that's good. And then the last couple here, using it as an assistant to help you research topics or technology. So as we go through the class, we might have things that are a little more open-ended where I'll say, hey, go out and research this particular thing. Tell me what you find. AI is a great tool for helping researching. It's like a fantastic research assistant. But if you just say, hey, AI, go out and research this and write a report, and then you turn in that report to me, then and you haven't even read it or looked at it and you don't understand it, that's bad. In other words, think about using AI as sort of like if you if you go to the gym to work out and you hooked up a machine to lift the weights for you, you're never going to get any benefit from it. AI can be like that machine at the gym, or it can be like a personal trainer at the gym that helps you maximize your effort and your training plan. So try to use it as that, or I would say definitely use it as that. Do not use it as the thing doing the work for you. Use it as a coach, a tutor, an explainer of difficult things, a second opinion on stuff that you're working on so that you can understand it better. Don't get it to do your work for you. And also, when you're using outside resources, whether it's a large language model or somebody else's code you found on the internet, do cite that. So if you're writing code, put a little comment in your code at the top that says what resources you used, what references you use. If you're writing out a short answer question and you got information from somewhere else, cite that. In other words, don't plagiarize something or don't use somebody else's intellectual property or idea without some sort of attribution of that. Now, course policies. The syllabus does have other information, links to other resources, other course policies. Do read that, look at that carefully. And as a quick review of that, looking at that, if you go down to this course policies section, you'll notice that it has some information about when you can drop the class, the incomplete policy, more stuff about academic integrity. There's the AI policy we just talked about, exams and quizzes. There's also some stuff in here about accessibility and ADA requirements and links to the accessibility services office if you need to take advantage of that. Title IX statement, this Ohio Revised Code statement that's related to religious observances and religious holidays. My policy there, again, is religious or otherwise. If you're here because you want to learn this stuff, if you need flexibility for whatever reason, whether it's religious or I don't know, it could be a family reunion that happens once every 10 years. Just communicate with me. Let me know. I'll try to be flexible and work around that as much as possible, as long as it's something within reason and it's not something that's being abused. But just again, communication is the key to that stuff. And then there's some stuff here about canceling or counseling services, the library resources, and then career services on there as well. So do look at those things. If necessary. And those will always be on the syllabus for you on the course page. So look at that. You can always go to back to the syllabus and find that information when necessary. Okay, now, next up, what I want to do is I really want you to think about why you're here, why you're taking this class. And this is something in a graduate class should be less of a concern. In undergraduate, I always have students that seem unclear about this. And I kind of have encounter these kind of attitudes of like, oh, why do I have to do these labs? This is a lot of work. Or is this stuff going to be on the exams? I don't want to learn this. Or I hate these quizzes. I have to think. It makes my brain hurt. Or his exams are awful. I've got to like study and I have to work through this. I just got to get through this class or this degree, and I can't wait to be done with all of it. And what I'd like you to do is kind of take a step back and kind of think about a little bit different perspective than those. Those are all really kind of negative perspectives that you're viewing the class and the opportunity that you have in this very kind of negative light, as if it's a burden. In other words, why do I have to do this? Why is this being forced upon me? Why I hate this? And what I want you to do is kind of in this class, I mean, we're talking about AI and machine learning and getting machines to kind of do things that our brains do. It's really, to me, it really is a form of magic. It should not be something that seems like, I mean, sometimes it might be challenging. Sometimes it might be take a little bit of effort to figure it out. But at the end of the day, it's like, this is the stuff that humans could only dream of. And the amount of technology that's gone into like making the computers and the integrated circuits able to do the kinds of stuff we're able to do now is really almost magical. It is magical in a lot of ways. It's ridiculous how powerful computers are. It's ridiculous that we can take our ideas out of our heads and put them into a machine that can run things at kind of these almost near light speeds, billions of operations in a second, where our brain runs at 100 operations in a second. It's a superpower. And so don't think about it as, why do I have to do this? Think about like all of the things you're getting from it. So what I want you to do is kind of think more in terms of, I get to do these really cool things and learn these really cool things and experiment with this. And it's think of it as opportunities. Think of it as the quizzes as not a burden, but, oh, I get to test whether I learned this stuff. I get to kind of gauge my own understanding of this. Did I understand that or not? And kind of view it kind of like I think it helps to view things kind of like unlocking an achievement in a game. Like you play a game, if the game was super easy and it had no point to it other than you just sit there and you press a button and the thing goes beep, the game wouldn't be rewarding or fun. What makes it rewarding and fun is you accomplish something. And that's what I want you to think of in this class. But unlike a game, at the end of this, you're going to have knowledge and skills and understand stuff that's going to give you power over things in the world. So I want you to kind of, as you go through, when things get sometimes frustrating or tough, or where you're debugging your code and you're like, oh, I can't figure out why this code isn't working, just take a step back and think of it as, oh, I'm solving this mystery of why my code isn't working. It's actually kind of fun. It's like a little murder mystery where I get to play detective, but I'm also the killer who made the bad code that I get to figure out why it's bad. And so a change in perspective can really go a long way towards helping you learn this stuff, but also enjoying what we do in the class and making it something that you're going to be likely to use throughout, or have it be transformative for how you view what we learn in this class. So I want you to think, I can't wait to learn this stuff, or I can't wait for the next thing that we're going to learn in here, because it's going to be something really, really interesting. And the stuff we're going to do in this class is really useful and very interesting, and we're going to get to see it do stuff. It's not like we're just going to talk about things. We're going to see stuff happen, and that's going to be really, hopefully, rewarding to you. I don't know if you can tell, I'm a super nerd, and so I still get excited about writing code and seeing it do stuff. Here's this thing that was in my head, and now it's in the machine, and it's my parts of my brain in the machine now doing that thing. Um, Now, my teaching philosophy is the verb phrase to teach doesn't make a whole lot of sense. And now, from somebody who teaches, uh, you might think like, well, that doesn't seem to make a whole lot of sense. Like, why would somebody who teaches say to teach doesn't make a lot of sense? So I'm going to pause there for a second and give you a little bit of time to think about that. Why would somebody who teaches think the idea or the verb phrase to teach doesn't make a lot of sense? Oh, and by the way, if you hear dog barking, Loki is here behind me, so he has some anxiety issues, but he's sleeping back there in the corner. But if he hears things, he might bark, and it's windy out today, so there may be some uh, him uh, creating a racket here at some point. So don't be alarmed. Okay, so back to the question. Now, the reason why I think the verb phrase to teach doesn't make a lot of sense is most verb phrases like that, like uh, to drop, to hit, to push, uh, those are all verb phrases, action phrases that the thing you're taking the action upon doesn't have a choice in it. So, for example, uh, I have to have this rubber coaster thing that I've been playing with. If I say to drop, as soon as I do that, it just happened. It had no choice in that. Or if I say to throw, and I throw it, it had no choice in that. It's going to happen whether it wants that to or not. But the verb phrase to teach puts the emphasis on me as the professor or the teacher doing something to you. I am teaching you things. And I guess I don't think that teaching, at least real teaching, can work as me being the active entity doing something to you as the students. Um, I think a better philosophy is that I want to be more of your guide, like a Sherpa leading you up this mountain and showing you the kind of the path that I think is the best one. And maybe if you get stuck or you get worried about that path, or there's a path that doesn't feel right to you, maybe I say, well, let's try this other way. Let's take this alternate route, backtrack a little bit. Let's try another approach to it. And so, what I'd like to do in this class is rather than me just doing something to you and you like uh, passively having this thing done to you, I'd rather have it be more cooperative or collaborative where I'm guiding you and you're giving me feedback to say when you're struggling and then letting me help you. So I'd rather be more of uh, your like I said, your guide leading you up the mountain. And if you think about that, it's also going to be a lot more enjoyable. If you think about, okay, we want to get to the top of the mountain. Well, if you're the passive entity and I'm the only active entity, that I would like, for example, I don't know, throw a rope around your waist and then drag you to the top of the mountain over the rocks and the rubble and the scrub brush. And by the time we got to the top, you would be all scraped up and really sore, and it wouldn't be much fun. And you really wouldn't have learned how to get there anyway. You wouldn't have learned where to put your feet, how to take the steps. You wouldn't have gotten any exercise and used your legs or your brain to figure out the route or your muscles to pull you up there. All you'd be is sore and tired and angry and scraped up and bruised. And I don't want this class to feel like that. I want this class to feel like we're kind of going through this material together. I'm helping you go through the material. And that way, when you get to the top, you feel like you did that you knew the route to take because you learned the route to take, and that when you got stuck, that I helped you. So I want you to think of yourself as being more active than passive in the education. Now, that also means, though, that if you get stuck, I want you to reach out. I want you to ask for help, uh, uh, either in the chat or by email or text message, by phone call, however. But I do want you to say, hey, I'm struggling and I feel like I'm getting left behind, and I will come and meet you where you are, and we'll try to find a way to help as we do that. So again, think of it as a collaborative effort, not me doing something to force you to do something you don't want to do. Think of it as you want to get to the top, and I'm your guide, and I want to guide you to the top. I really do think this material is interesting and cool and fun, and I think you will too. But you won't think it's that fun or cool if I'm just forcing it upon you and making you do stuff that you don't want to do. So come with me, follow me up there rather than having me do things to you. Now, the other part of the course philosophy that I think is really important, that's guiding how we're going to do this class, is a quote from the famous physicist Richard Feynman. And this is actually, that picture in the middle is from he wrote that on a blackboard, and I kind of cropped it down. There's a bunch of other stuff written around it as well. But he wrote, what I cannot create, I do not understand. And I think that's a really valuable or invaluable perspective, meaning that if you can create something, if you can build something, then that means you really understand it. And that's what goes back to what we were talking about earlier about the black box approach and us avoiding that. That I want this to guide my approach to the class. In other words, I want us to build things in order to understand them. I want us to not just rely on something somebody else built and say, well, that's good enough for me that I played around with something somebody made. I would rather have it where you have built things, you have made stuff all the way down from scratch, all the way up to where we are, and that you understand all of those bits and pieces of that. And so if you can do that, then you truly understand. And then kind of another, I guess, hopefully future famous quote, and this is from me, to truly create, you have to first understand. So to truly build things of your own in the future, to innovate, you kind of have to understand to create things. You have to be creative and build new things. You have to have a level of understanding that allows you to take that understanding and then put it into action. And then kind of a corollary to that is to fully understand, you must first create. And so these seem to be kind of cyclical or self-referential. In other words, to understand, you have to create, but to create, you have to understand. And so really, we just have to get started, roll up our sleeves and get started doing both of these simultaneously. And I've termed this the Paul's paradox of enlightenment. But the idea is, if you want to understand something, start trying to build things with it, even if you don't understand it at first. And the more you create stuff, the more you build things, the more you're going to understand. And the more you understand, the easier it gets to build more things. So that's what we're going to do in this class. We're going to start out slow. We're going to build up through more and more interesting and useful and fun things. But it's kind of like everything else. The more tools we have in our toolbox, the more capable we are. And so that's what we're going to do, is we're going to kind of break into this paradox, this cycle, by kind of understanding some foundational things and then start creating some things that are going to then lead us to the next things that we can understand, to the next thing we can create. We're going to kind of bootstrap our way up to doing some really cool things by the end of the semester. Now, what are we going to do? So quick overview. We're going to be learning about some kind of philosophical, conceptual, semantic things related to AI. We're going to be doing some computer science and learning about that. We're going to be learning information theory. We're going to be learning about patterns and language and how information theory and computer science relate to that. And ultimately, at the end of the day, you can tell that from the title of the class, we're going to be doing artificial intelligence, machine learning, and all of the kind of shades of gray in between those two things, and that's what we're going to be learning about. And then what we're going to be doing is, again, back to that paradox, we're going to be creating in order to help us learn. And what are we going to create? We're going to write code. We're going to solve problems. We're going to come up with solutions and experiment with those things. And in order to build that understanding through our creation, we're going to be doing kind of exercises and experiments and doing and creating stuff like we mentioned earlier. And that's going to become this like nice kind of feedback loop of understand something and then use that to create something. And then what we created, we're going to learn from that and then use that to kind of guide where we go next. So it's kind of like exploring the deep, dark woods of artificial intelligence and machine learning, where it's going to seem spooky and maybe a little intimidating at first. But the more we kind of wander into that, the more we understand bits and pieces of it, and more we kind of stake out some ground in that, the more fun and exciting and exhilarating the exploration is going to become. So at the end of the day, we're going to be having a lot of fun. And that fun is going to come through exploration, experimentation, and creating things. So we didn't really cover much in the way of actual material today, but that's an overview of what we're going to do this semester. Next class, we're going to be digging into some actual material and start talking about like specifically these philosophical and conceptual things. And then we're going to start moving into actually creating and building some stuff shortly after that. So we'll take a break here. I'll pause or I'll stop the video. And when we return, we're going to get started with some content and some questions that get at the heart of the course. And again, this course is Artificial Intelligence and Machine Learning. This is Artificial Intelligence and Machine Learning 1. And hopefully, once you guys get a little bit farther into this, we're going to be having a really good time building things that we can learn a whole lot from. And one of the things I like about AI and machine learning is that not only do we learn about that as a subfield, but it's also really interesting because we can learn things about ourselves as humans and what intelligence itself means. And sometimes that's not an easy question to answer. So we'll go ahead and stop there. And I will see you guys in the next video. So everybody stay safe. And we will be back shortly. And again, if you ever want to review any of this stuff, remember, look at the lecture slide deck, and on that first or second page, there's a link to the video presentation of the material, and that will be true for all of the lectures throughout the semester. All right, see you guys soon.